All right, hello everyone. Thank you for coming out on this beautiful Friday afternoon. How many of you guys are responsible for building machine images? A lot, maybe, yeah. Any of you used Packer before? A few of you? Cool, so sweet. This will be new information, I'm excited. I love Packer, and I use it a lot. And I'm not even an ops developer, I'm actually just a regular developer who's been pretending to do ops for the last few months. So, yeah, so let's get started. I want to begin with a story that happened to a lot of us probably starting 3 or 4 months ago, and I like to refer to it as the reboot that was heard around the world. And of course, I am referring to what happened in early January when we were all sitting around staring into our lovely Tmux terminals, and some of our Amazon nodes started force rebooting, and then also on Azure, and then eventually on DigitalOcean. And some of them maybe didn't quite come up correctly, and there was a lot of the internet that was struggling at the time. And simultaneously on Twitter, we could see these blog posts floating around talking about speculative execution. I don't know. We gave it this funny logo, though, and called it Spectre, in spite of the fact that it was really a rather bad security vulnerability. And as a result of Spectre, I am obviously describing what happened whenever all of us had to, or a lot of us had to patch our kernels if we're running on Linux systems and reboot them, and thankfully a lot of our cloud providers started doing that automatically for us. And as a result of that, maybe not all of our servers started up in a way that we would expect. For instance, I had a blog that was hosted on a remote server that had been running for, I don't know, 4 years or so, and had some various services that were running on them that maybe I set up by hand, or had some specific configuration that didn't persist after a reboot, or did some sort of weird thing that I didn't expect when it started up. And indeed, some of our work servers went through some of these same problems as they started rebooting across the internet. And that's why some of the services went down. I'm sure we're all familiar with all of the fun ops work that we had to do last January. And what I'm describing is another thing that we have a somewhat weird and cute name for, which is snowflake servers, which describes the case in which we have a server in production that has somehow become very special and become a snowflake and separated from the original machine image on which we deployed it to, right? Like, we deployed machine images, and over time they tend to change. We have to do some fix, we have to SSH into it and do something to it. And at that point, whenever we redeploy that image, it's very different, right, from what actually exists in production, which leads to some unintended consequences. Now, as talented ops engineers, as we all are, we're aware of the concept of immutable infrastructure, which is the idea that we should never do that. We should only ever build and deploy machine images that are ephemeral, that are something that we can throw away and build another one, but we always build the image and then deploy the image. We don't change it once it is already on the server. And there are many tools around for solving this problem and for building up immutable infrastructure and for handling the types of problems that you need to solve whenever you do this. And the one that I want to talk about today is Packer. Packer is a relatively small binary. There aren't a lot of dependencies. You can just download it and unpack it and run it. It's super easy. It's great. And we are going to outline, or this is the outline, of the few major topics that I want to hit. First, we're going to investigate a little bit into how Packer works and like what the individual bits and pieces and things that you need to know about Packer are. And then talk a little bit about how we have, or how my team and how I myself have found use cases and like good patterns for using Packer, and what types of problems I've been able to solve with it and why I enjoy using it so much. So this is an overview sort of what the Packer architecture looks, or what like the Packer process is, and I want to break down a little bit each individual part of this. It's not really as complicated as it looks here. This was kind of as simple as I could break it down in a small image. But on the far left there, you see the image template JSON. That is just a regular JSON file that Packer calls a template. And that describes your build process for your image. That is like the key building block that you're using in Packer. And basically, you just pass that to Packer with the build argument, and it will follow the instructions that it finds in that JSON. There are three main parts. I think all of them are optional except for builders. But there are three main keys that need to be defined within this JSON file. The first one is a builder. And a builder is something that takes in, depending on the builder, it can take in an ISO file or like a pre-built. In the case of Virtualbox, you can like bring in an already set up Virtualbox and then build on top of that. Or you can take just like a raw ISO off of the internet or any number of other things, depending on the builder. And then it outputs another artifact. And then that artifact is then passed to the provisioners. And those provisioners are responsible for doing any sort of post-OS install type of configuration. Packer supports a large array of different provisioners, and they can be very useful for setting up specific service and doing any sort of configuration. You can even set up things like Ansible and stuff like that on it. And then once that's done, you have the output artifact from that, which then can go to some additional ones. The one that I find myself using the most often is the post processors. And there are many different post processors available. You can use post processors to like compress an artifact. You can use post processors to upload it to a specific service if you want to. You can output to Docker. You can build a Vagrant box. There's all sorts of things that you can do at the end once you have your machine image set up. And so that's sort of the 1,000-foot view of what Packer is doing. And then we're going to cover each individual little piece real quick and talk about sort of how they fit into the situation. The first one being the builder. As I said before, a builder takes some sort of artifact like an ISO, or you can use a snapshot from DigitalOcean or a pre-existing AMI from AWS, or it also supports like Google Container Engine, Azure, like it supports a lot of stuff, like VMware, Virtualboxes, all kinds of different inputs that you can feed into it. And then a lot of these have like multiple different sections you can use. So in the case of Virtualbox, for instance, you can build on top of either an existing Virtualbox or you can build on top of an ISO. And so basically the builder takes in this specific artifact, and then you specify, like you sort of outline where you want it to go and like specific attributes about that. And that's really, I mean, basically about it. The other thing interesting about builders is you can have multiple builders for like in the same pipeline. So if you want to take your Ubuntu server image that you've pulled down or like your Windows server image that you've pulled down and then have a builder for AWS and DigitalOcean or have a builder for VMware and AWS, you can then output like AMIs and like Vagrant boxes and stuff all through the same pipeline, which is one of like the big strengths and draws, I feel, of Packer, is its simplicity of setting up those sorts of pipelines. The next piece is the provisioner, which I talked a little bit about before. These also have a wide array of options that you can use for a provisioner. You can use Ansible, Chef. I tend to use shell scripts and just plain shell commands a lot just because of the types of software that I'm usually deploying. But you can get very complicated and build up very robust in spite of the fact that they have lots of configuration pipelines using these provisioners. It sort of is a way of documenting what sorts of post-OS installation steps you want to take. If you want to install any libraries, do that sort of thing that will be saved in the next like machine image artifact that's going to be moving forward. And that's the use case for provisioners. There are a few examples there on the right. All of this is documented, so I didn't like put any huge examples on there, but they're really pretty basic, and like you just run playbooks or run shell commands. You can copy and run scripts, like shell scripts. That's what I usually do. They're pretty handy for setting up some stuff. Question?
The chef option, is that chef solo only, or will it interact with the chef server?
They have both. Yep.
And follow up. So you start with an OS and this net is installed. It'll just install as part of the fact that it's not provisioner, or will I have to say install this before I
That's a great question. If you want to use something like Ansible, it will need the Ansible binary in the path. So you'll have to, like, you'll have a shell provision or right above that. That's like apt-get install Ansible or whatever. Yeah. And I'll talk about a little bit at the end. There's some examples of different ways that you can set that up. But yeah.
I'm glad it's not like that.
Yeah, no.
I sort of like that.
Yeah, great question. Okay, and then lastly is the post processor, or the last piece that I use a lot. This is really the most useful part of this for me is building vagrant boxes. So you can take an AMI off of AWS, apply some configuration to it, build a new AMI for AWS, and also have a local vagrant box based on that same image. And the same thing from snapshots for DigitalOcean, or basically any other ISO that you can feed into a builder, which is really helpful in keeping parity between your dev and your test and your production environments. You know, there's less of this, well, it works on my machine, but it doesn't work on this random image and even you can run into those issues if you're downloading ISOs and running them in VirtualBox that maybe Ubuntu 16.04 or something, and then also like that image can be slightly different from the image that is in DigitalOcean or in AWS or in any remote environment really, unless you're deploying the exact same artifact. So part of this reasoning is that you have the same artifact all the way through that you can run. And the last thing that I want to make sure that we are aware of, and a thing that's kind of weird, up until this point, I've sort of been hand-waving over the whole ISO into the builder part. If you want to use a raw ISO, absolutely, maybe a better way to start this discussion would be the easiest intro into this would be to use a pre-built image from AWS or a snapshot from DigitalOcean or any other already made deployment artifact. Because at that point, the OS has already been installed and configured in such a way that it runs on your virtual machine. However, if you are really bored or you like to, for security reasons, have complete control of the entire build process from ISO to application server, you can import ISOs. And the interesting things to note about doing this are you have to specify this extra key up here in your builder, which is the build command. And it's kind of weird. There are a number of individual key presses and things that are documented and different sort of macro things that you can use. It's basically an array of strings that it will insert raw into the ISO as it is running. So the idea is that it boots the ISO and then it starts the installation process, and then each one of these individual commands get run. And they're kind of weird looking. If you look at examples, you'll see ones that are like press escape twice, press F6, press backspace 37 times, because it's basically dropping out of like that GUI that's like trying to install things and then trying to get to a place where it can do an install in a scripted way, so that every time you set up the OS, it's setting it up in the exact same documented manner. The other thing that's interesting is the pre-seed config file. Whenever Packer starts up, it actually boots a local server serving static files from a specific directory on your computer that you can tell it to. And usually what happens is you set up a pre-seed config file, like this example down here on the bottom, that has specific configuration instructions for the image that you are using. And then what Packer will do as a process of building up the image is it will connect to that server, pull in that file, and run those commands. So those two things sort of work together to build up a like working ISO that is past the whole like operating system installation step. And it's kind of odd, but you can find, thankfully, a lot of examples of existing like build processes for different images from ISOs, and I have a link to those at the end. I will post my slides on Twitter after this. That's really how I learned like most of these commands, and most of like the config file settings for different operating systems were from poking around from other open source projects on GitHub. And so those are two things to be aware of if you want to build from raw ISOs. So with an overview of sort of how Packer works, we can now talk a little bit about how we can use Packer to improve our development and deployment workflows as engineers. being able to document the config files, the boot commands if you're building from a ISO, and additionally what base AMIs you're using, what JSON template you're using, et cetera, is incredibly invaluable if you are working in a team of many people who may or may not have a lot of like ops knowledge, or if you're working with other developers, because it gives you a sort of version controlled way of understanding what sort of changes are happening to your base machine images and being able to track over time how each image moved forward and then being able to roll back. Like at work we use, or I have used in the past pipelines that involved where we would only keep like one previous artifact. And so, but if we needed to go back further, we could do that easily because we had like tagged releases in, you know, Git or in whatever version control that we could, because the entire build process of the machine image is checked in and as text files, you are able to recreate these images as you go along without having to keep the actual artifact around for each individual release step, which made rollbacks to like much previous version and doing like A/B testing and stuff like that much easier because it was all well documented. It sort of touches on continuous delivery and integration pipelines. If you have a easy reproducible way to build machine images, it makes it much simpler to like sort of set up Jenkins or to use something like Circle CI or to use, I know a lot of people right now are moving towards like using Docker as sort of a proxy for this, but you don't have to use Docker. You can build from raw ISOs to specific artifacts that you can use in these pipelines. And a lot of times, I mean, this is, I think, in my opinion, simpler and makes things at least a little bit easier to reason about, especially if you're not like an expert in all things operations like myself. And then probably the most powerful use case, probably the most powerful use case I've seen for this is because you can use multiple builders and post processors, then you can set up like a single Packer file that can like pull down machine images or build up images that can, one, be deployed to a variety of systems of remote, like cloud-based providers, and two, can be run locally via Virtualbox or Vagrant, or like you can have all of this in sort of one central place to sort of break down the line between development, test, and production, and to like streamline that interface of being able to easily get an image that you can run locally that is as similar as possible as an image that you're deploying to production, using the same sort of, using the same build process, using the same provisioners, being able to test all of that, I have found is like super invaluable. And because there is so many different supported backends for Packer, the ability to use like VMware or Azure, or like any of these different setups has been very useful for me personally and on different projects, consulting and such. And then lastly, a example that I have found it helps out a lot in for any, one language that I've been deploying a lot of code for in the last year and a half is called Elixir. And Elixir is a language that is like built on top of Erlang, so it has to like be compiled down to Erlang and run on the Erlang VM. And it has a really great packaging and release system where you can deploy like these almost like these self-contained binaries that you can just ship to a system and it doesn't even have to have Erlang installed on it, which is really cool. But the kind of weird part about that is because of the way the Erlang virtual machine works, that whole environment has to be built on a similar architecture, or almost exact architecture if you want it to be very sure that it'll work, as the architecture that you are deploying to. And so as a result of that, there's in the community kind of all these weird ways of like building in Docker, like setting up a virtual machine on AWS and building the release and then copying the release local and then uploading that to S3 and all of these weird steps. But with Packer, you can set up an image that is like based on the same machine image that you can, that's based on the same machine image, but has like the specific things that you need to do to be able to build the release, and then also the specific things that you need to do to be able to run the release. And you can have those all set up in the same pipeline, which is super useful and handy and easy to reason about and document and onboard new people to using, at least in my experience. So those are sort of some examples and ways that, I mean, I've been using Packer. It's pretty great. I like it a lot. The last bit I want to leave you guys with are some links. Like I said, I'm going to tweet these out after this, so that, and I'll put my Twitter on the end. But these three are really good intros. The Packer documentation is great. There's like a brief intro on Packer's website about like how to use it and stuff like that. But for getting more in depth, I would highly recommend looking at other people's templates. And this repository at the top has a ton of templates for a ton of different operating systems. And it includes like the config files, and it includes boot commands, and it includes all kinds of stuff. You know, if you want to reverse engineer a boot command, go for it.
Does it by chance have specifically Ubuntu desktop, not server templates starting point?
Okay, so the question was, does it have desktop and not server start points?
Yeah, because I can, starting with Ubuntu server, there's lots of versions of that.
Right.
And I don't have to go from server to desktop, but it's possible. I've got some examples where they go from server to desktop, and for example, if you bring up the command, and it just is behind, you have to fix the generated thing from packages. It doesn't quite work right.
Right, okay.
If you don't know, I'll look.
No, it's a good question. So the question is about the difference between the server,
Starting from Ubuntu server versus desktop, because
right, the Ubuntu server
that you do
are very different. Yeah, that's totally correct. I don't think this repo has the non-server Ubuntu. I think it just has the server version. But if you have, what I have found myself doing is taking an ISO, booting it into Virtualbox, and then walking through it, and then writing down the commands, which is kind of annoying, but it works in a pinch. But yeah, that one has, those are mostly server templates. I'm pretty sure there might be one, but
that's fine. For your use case, server templates make more sense.
right.
Have you seen the box cutter versions of some of these things?
I have seen the box cutter versions. They're very good.
It has a lot of templates as well.
Box cutter has a lot. That's also another great resource. I should have put that on there. I didn't even think about it. The Packer tutorial for beginners, that sort of covers walking through using AWS AMIs, which is similar to the Packer walkthrough that's on their website. If you don't have an AWS or account or whatever and don't want to work around with that, I would highly recommend taking one of these template repos and just setting it up in like VirtualBox or something and playing through it a few times. Then you don't have to like set up any weird credentials or fight that battle. And then this last setting up images with Jenkins and Kubernetes is a really great post from Google that gets a lot more in depth about like sort of setting up containerization and pipelines and how you can use that in a productive way. Yeah, and like I said, I'll share these out. I'll share all the slides out on Twitter, so you don't have to write all those down or memorize them by heart or anything. And so in closing, the point of this is just immutable infrastructure is something that we should all be aspiring to. I know it's sometimes difficult and things always diverge from where we originally deploy them to, but thankfully Packer is a really great and simple tool to help support us in those endeavors of keeping things all together. And it's not, unless with the caveat that if you want to build ISOs or from ISOs, it's actually not that difficult. Using snapshots from DigitalOcean or AWS, like you can be really productive with Packer in like 30 lines of JSON. Like it's really pretty cool how easily you can document exactly like what changes are made, what what dependencies are installed on each image, and have a reproducible way to build those images and use them locally if you need to. And if you're really adventurous, you can also build from ISOs, which is a lot of fun. And that is all I have. So hopefully it was informational. If you have questions, please let me know. My name is Paul Dawson. I am Pi is a lie on Twitter. I blog at Cannot Into Computer. and I work for a consultancy called Citrus Pipe, and that's it. Thank you. So questions? You guys are easy.
Comment. I want to double down on the notion of using an environment for dev. I mean, I've been
Okay.
on 4 different projects, and it is, I resisted it the first time, and I drank that Kool-Aid years ago. And my poison is Vagrant Chef,
Mm-hmm.
and I haven't dabbled with Patrick, my care has. And you implicitly answer some questions about why one versus the other, basically. Patrick seems like a lot less work than, say, Chef, or Chef, sorry, Vagrant Chef, or Vagrant.
Yeah, I would agree with that.
But, and in fact, in our most recent example, even though we didn't automate it, we had a script that set up the environment. I found that because we're doing some Windows tenants, the Windows stuff, the stuff in the virtual machine ran about an order of magnitude faster than outside because I didn't turn on things like fire protection. Because I can throw it away if something goes wrong with it, and it doesn't have a connection to my inside box. So I set it to my box, it allows me to work fast, and when things go bad, it's immutable, dump it on the ground, and you're good to go. So it's for development, and I have no patience for what works on my machine.
Yeah,
I don't care what the hell did you do to your machine to make this work? Right?
I agree with that a lot.
There's so much better things to spend your time on than stupid infrastructure stuff. So I'm very thumbs up on this.
You said from the developers you use
The box that I use, yeah, so even though I've got a Windows box, I went to moving into a virtual machine running on my Windows box with Windows to do my development. ID and everything. And I don't put the files out because, like, if you use Virtualbox, I don't know, or if you use Virtualbox, file sharing is slow as hell. So I go all in. And I've done this with Ubuntu, and I've done this with Red Hat, and I've done this with Windows. The value to me of having a reliable, repeatable, definable environment that gives you predictable results is, and also one that's really close to your deployment environment so that you don't have any surprises, is so valuable that the maybe 5% difference in performance on modern hardware that you get by running raw, it's just not worth it.
Yeah.
I've seen an example before, but it's only for Golang where someone wrote something that basically was a watcher for Golang. You did all the development IDE, everything local with everything, finally made a change and saved it, watch, build it, run, instead of doing Docker, and run the tests and everything, and then just order Docker.
So if you're using, sorry.
Oh no, I was gonna say, you had a question.
Yeah, so maybe you can expand on this a little bit, but this looks like it solves my biggest pain point with Vagrant, which is I've been in places before where we have a developer in Vagrant environment for like, hey, new developer we're onboarding, here's your dev environment. But our image is so old that you can't run a current version of Vagrant because we're so scared to touch our image that it's going to break. And so you can't run, you have to download a bunch of old libraries and stuff just to get the image up and running. This seems like a solution for that pain point because you're able to rebuild new images in current versions or current versions of Vagrant all the time.
So the question is this a solution to having,
Stale images.
right,
for development.
is this a solution for dealing with very stale Vagrant images, Vagrant boxes that may or may not boot up from base images as expected? Yeah, I mean, I think in that case, I would probably, like, if your target operating system is like CentOS or like Debian or something, like, I would probably set up a Packer file with that, and like set my target image artifact as like the base, and then be like, and then build from that until I get on the other end a Vagrant box that outputs what I want. Does that make sense? Like, you can definitely use it to that end. And like, I've used it before on like AMIs where we're not really sure what the configuration is, right? So you can take an AMI off of AWS or some other machine image that you have that you know is working in some way, and then pull that down into like a vagrant box or something via Packer, and then use that vagrant box to test against, and then start your new image, like whatever build process that you want, and then at the other end have a vagrant box, and then that way you can sort of A/B test them. Does that make sense? Does that answer your question? Okay.
Have you done anything with getting like test results off of your Packer images? Like for example, we're building a very customized Windows server. We want to like run a tester test on it to make sure that everything is installed properly, and then get the XML results from the tester run off the box, so our CI box can say yes, this image passes.
That's a really interesting question. So the question is, have I done anything with getting like test results out of an image after like tests have run or whatever, like getting something out of the, like building an image, running some command, and then taking the result of that out of it and like analyzing it in the case of like CI or something, in your case tests. So that's sort of how the Elixir pipeline works, where you have to like build an image, put your code on it, and then compile the code, and then take like the result of building that release is a tarball that you have to take out and then like upload to S3 or do something with. And so like that's definitely, yeah, something you can do. I tend to do it with just shell scripts. I don't know if that's an anti-pattern or not, but I don't like, one of the reasons why I avoid using, or why I don't like using Docker. I've also used like two-stage Docker containers and stuff like that to do something similar, where like if tests output an XML file, then you can move the XML file into the next and then test against it in there. And one of the reasons I tend to lean so much on shell scripts for copying stuff around is just because that's easier for me to reason about. Once you start adding more and more tools on top of the chain, then it just gets confusing to me. So, question.
So I don't know much about Terraform. I just know that it's kind of like a code as an infrastructure. Is Packer something that, I don't know, does it overlay kind of some of the use cases of, well, actually, I think you know much about Terraform either. I know some of you do. But is this kind of a replacement for that? I know they're both new, but where they overlap in some use cases?
So that is a great question. The question is, how does this interact with Terraform? Like, do they do the same thing, and how are they related? And that's a great question, actually ties into the question that you just asked. Usually, so Terraform is a bit different in that it is more for provisioning hardware. So you can use Terraform to say, give me this VPS and these subnets and these 5 servers on EC2 on AWS, do it, right? You can describe that setup and all of your security rules in your Terraform file, and it'll spin all of that stuff up. And it will reference, when you spin up like EC2 images and stuff like that, it'll reference like AMIs or snapshots on DigitalOcean, or you can give it images like, do this thing over here. Does that make sense? So then Packer works into that pipeline by creating the images and the AMIs that you would use. So in the AWS example, I've used Packer to build AMIs, and then I've used Terraform to say, give me 3 servers with these AMIs on these subnets with these security rules and this load balancer, right? And so that's sort of how it works together. And in the question that was asked just previous to this one about analyzing things within an image that have run, like for instance, tests, or getting some specific piece of code or result out of an image after it runs. I have actually used Terraform for that, where I will say, spin up this base image that has everything that I need to run tests, and then you can use Terraform provisioners to copy all the tests into that base image that Packer built, and then run the tests, and then output whatever the result of that was back to your local system, and then tear down the server. So that's sort of how I use them working together. Does that answer your question?
Yeah, I guess it's Packer. So I think Packer was actually doing spinning up droplets or EC2 instances or all that. Is it just building an image and you do that later?
Yes. In the case of like droplets in DigitalOcean's case, for example, it saves snapshots. It doesn't build you a droplet, but you can set it up in such a way that it will give you a snapshot on DigitalOcean. And then later you would use Terraform or the interface or whatever you want, their API, to spin up an image from, or to spin up a droplet from that snapshot. And then the same thing in AWS. They use AMIs. You can spin up an EC2 instance from an AMI, stuff like that. So, question?
So the Terraform question, this solves a problem, Terraform for me. And it's not a question. There's a problem in Terraform where Terraform spins up my stuff in whatever cloud provider I need, gives me a server running out there in the world. And then there's this weird step where I do stuff to that server, and then I hand it off to my configuration manager, whatever that is. The doing stuff to the server, where the line goes from what should I do in Terraform to what should I let my configuration management tool handle, what do I need to do to get it ready for that configuration management tool, is a weird, it kind of tends to get bloated in Terraform. This moves that earlier to say, all I really need Terraform for now is my infrastructure, but I'm letting all of the getting it ready for my configuration management as much as possible anyway happen in the building of the actual image itself. Then I can hand that image off directly to my configuration management tool without having to do a bunch of orchestration before I do it. That
Yes.
seems reasonable.
So the question is, can we use Packer to manage the inevitable bloat in Terraform remote provisioners that set up a ton of crap before we actually hand it off to a provisioner? And I think definitely yes. Like I tend to, I don't know, I can't say that I'm like, I'm not an expert by any means, but I would say I tend to lean on Packer much more for setting up images and getting them in a state that I can deploy them so that Terraform doesn't have to deal with that. Because, I mean, one of the awesome things about Terraform is it is also super powerful and you can do a lot of stuff with it, but that's maybe not the best place to do it. All right.
Thanks, Paul.
Yeah, thank you. Is there anything else we need to?